Okay. So today we are going to conclude by learning about certain advanced topics in terms of software engineering. Advanced in the sense like we are just going one step further ahead after learning about after getting the introduction to what software is all about, what software engineering is all about, and learning about the characteristic features of software, understanding about the applications where this software is widely used, and learning about the software development life cycle, different models of software development or software engineering. Okay, what the entire software industry is having as its trend. Then after learning about a bit about the planning, scheduling, and resource allocation, what are the types of resources used for software development, like human resource, hardware resource, software resource, and economical oriented factors. What is the importance of planning? How to go for scheduling the project? Being a software project manager, how successfully we can go for coming out with the proper schedule, and how we can just to go for reflecting those schedules to our team. Okay, just getting to know about what is a bar chart, what is an activity network diagram, and then we learned about the design aspects related to what exactly a design of a software is all about. What are the different types of design, architecture design, high level design, low level design. Then we learned about the design principles. Then we learned about the design approaches, design principles. We learned about problem partitioning. Then we learned about abstraction, the role abstraction is going to play in terms of giving a kind of reflection onto the project, what has to be shown and what need not to be considered. Then we learned about top down and bottom up approaches. Then we learned about the coupling and cohesion concepts, which are very important in its own reason that why it is there in terms of the design. And then we came across the different types of design, like high level design. Then we learned about real-time system design, object-oriented design, like the way and all. Okay. After learning about design, we went to the third module wherein we learned about what is the importance of testing, why we need to go for testing a particular software, what is the emphasis that we need to give in terms of assuring the quality for the product that we are going for developing, what exactly we call it as the quality control practice that we are going to follow, and who are all the people going to test a particular product. And we learned about what are different levels of testing, like unit testing, integration testing, system testing, then acceptance testing. Then at what level these particular tests are being carried out. Then what exactly we call it as a black box testing techniques. We learned about the white box testing techniques. What is the difference that a black box testing is going to have in terms of white box testing? What are the differences that black box is going to have in terms of white box testing techniques? Then we came to the fourth module where we have completely shifted our gears onto the next level of software development itself. Okay, so that is nothing but we learned a bit about what is agile computing, what exactly agile is all about, why the industry is practicing agile, what are the benefits that the industry is going to get as a result of, or the teams are going to get as a result of following the agile as their programming practices, what are they exactly losing and what are they exactly going to gain. And we learned a bit about what exactly we call it as extreme programming, then rapid application development. Okay, so a bit of agile programming practices we are covered, and it is not going to end over there. It's the fourth module, because in terms of software engineering, if at all you want to learn something in advanced, okay, you want to make yourself specialized in one particular domain, means you can we can tell that you can get specialized in terms of testing, or you can get specialized in terms of agile development. Okay, so by keeping that in mind, we had kept these particular courses as a part of our syllabus. When you're going to come into the fourth semester, you'll be having a core subject, core course called as Agile and DevOps. What our students are learning now, your seniors are learning about that. So the process of learning about agile programming practices is not going to end up over there. The fourth module of software engineering itself, it is going to come to one semester ahead. Okay, it's going to come to further one semester ahead. Okay, so there also you'll be learning in detail. Okay, in detail in the sense like you are going to explore completely into agile and DevOps oriented project development. Okay, so keep that in mind. That will be a core subject wherein you don't have any kind of elective options. But elective, if at all you're looking out into, we have a course called Software Testing Tools. So whatever the kind of testing techniques that you learned, everything are going to be practiced in a practical scenario. Okay, we are going to take up a different number of test cases. We are going to come out with a different number of test scenarios, and we are going to learn about how successfully we can go for conducting a test in terms of the practical setup. Okay, while we are going for implementing a Selenium as a testing tool or any other automated or semi-automated testing tools, we are going to practice hand in hand. Okay, as a hands-on, it's going to be conducted. And again, as I told you, like these two modules or these two courses are conducted by industrial experts. Okay, maybe like next year, I don't know what is going to be the scenario, whether the industry experts are going to take from international countries or from local institutes they are going to take. But keep in mind, like right now it is happening in the form of an industrial expert from a software company who is into the testing field. He is conducting the course on software testing tools, and an international lecturer, okay, who is having almost 15 to 20 years of experience in software engineering, who is into Agile and DevOps. He is conducting the classes for your seniors from USA regarding the Agile and DevOps course. Okay, it's all happening through online. So thanks to this online way of learning, so we have to see to that, like how positively we can convert the situation. Okay, even though we are going for online, we cannot just tell that since it's online, many things we couldn't able to do. So whatever we can able to do in a much more better manner, we are trying to do that. Is that clear? So advantages over here is like they are going to get a kind of immediate knowledge what they are going to get as a part of their training when they go for having their career in terms of testing or into development. Okay, so say for example, you want to become a testing practitioner, you are interested in, you are very curious about that particular field, means while during the internship, you'll be given the kind of training. Okay, initially they'll give you the training, they'll make you to work with the project, and they'll make you to take up certain simple projects and ask you to perform quality measures onto that. Okay, so those things and all you are going to get to learn well in advance during your course period itself. So while you go for any kind of interview related to the testing domain, you'll be a kind of a person who is ready for the task. You need not be considered as a kind of novice developers who have a novice tester who has got a prior theoretical knowledge about testing, and he has to be given the kind of training that is required for starting up his career. Okay, that is not needed. Already you are trained and you can just straight away go into the task of performing the testing. So these are the advantages that you're going to gain as a result of being a person who is going to take student who is going to go for elective option on testing. Is that clear? So after learning about all those things, now we are into the next level, that is learning some advanced topics in terms of software engineering. Okay, having said that, learning some advanced topics in terms of software engineering, we should not forget like Agile is also an advanced topic, because not much people are exploring the Agile way of software development. It hasn't come into the common practice, or quite a huge number of people are not practicing. Massive practicing is not happening on Agile software development methodology, because people are having a kind of hesitation whether to take up this, or the kind of decision that I'm going to make, that my project is going to qualify for Agile way of software development or not. Okay, so people are in that particular mode only. Certain startups are having the courage to go for it, because they have the kind of exploring mindset. Okay, they want to find out, or they want to be smart. Literally, the idea is people wants to be smart. They don't want to just go for practicing again the conventional practices, and they know very well, like industry as it is going to move towards any kind of advancement in terms of software development, means it has to be in this particular area. One among the advancement is object oriented way of software development. Already that is in practice, and incorporating that object oriented programming practices, we are going to follow this Agile way of software development methodology also, means it is something like a more beneficial thing for the project development as well as for the project developers. Okay, so that is the reason why we are considering that Agile as one of the advanced topic. And along with that Agile, we are going to learn about software configuration management, what we are going to learn in the class today. And I'll be giving you as a self-study topic on something on secure coding practices and case tools. These two are quite a simple set of topic only, what you can understand, you can read and understand, but definitely do consider that you'll have questions for the examination from these two titles. Okay, the main reason why I'm giving this for your self learning is that case tools, computer aided software engineering tools. I might have told you about these tools in the first class itself. While we are going for developing any kind of project, in terms of hardware, means we have computer aided designing tools, or computer aided engineering and computer aided manufacturing tools. CAD, CAM, and CAE, they used to call it as. But when it comes to case tools, or when it comes to software development, it is these case tools that are available for us, computer aided software engineering tools. And when you are taking like, sir, what programming language is going to play a role here? Under is it? It's a tool, right? Programming language is also a tool used for software development. It is a part of a software development component. Okay, so if you're asking like, sir, then where I will go for considering this programming means, it will be considered under the programming language to be considered under a tool called a programming tool. Okay, like there we have some 6 or 7 number of tools which are being practiced in terms of its instances, in terms of their occurrences, they have been practiced without having the knowledge that we are practicing case tools. Okay, so being the developer, if at all you're going to learn of your own with that kind of understanding, then it will be the apt kind of study that you can do onto the case tools. That is what the reason why I am telling that you can go for doing as a self-study topic. Along with that, the secure coding is also a kind of a thing which is added most recently. Okay, because one of our BOS member from the university has insisted that students should understand what secure coding practices are all about. It's all about while you're going for developing the code, how you can just secure the code, how you can just go for licensing onto that coding structure that you have created, logic that you have developed, by making it available for the future users. Okay, since we are going to make it available for the future users, it is very important that we need to go for getting the license for whatever the kind of code that we have gone for development. We are just given for making the design to work or implementing the design. So that is what the reason why secure coding practices also you should learn of your own. Okay, the importance of it is the same. Is that clear? So we will with those 3 topics, this module is going to conclude. The advanced topics module is going to conclude. So the first topic under that advanced contents of software engineering is software configuration management. So before going into the contents, they're just starting with a quote which was given by Bersoff. Okay, what he told is, no matter where you are in the system life cycle, okay, system life cycle or software development life cycle, it's all the same. No matter wherever you are in the system life cycle, the system will change, and the desire to change it will persist throughout the life cycle. Persist means it will exist. Okay, so no matter whatever may be the kind of project that you have chosen, what are the kind of programming development methodology that you're going for adopting, programming practices that you're going to adopt, or technologies or techniques that you're going to adopt, okay, your project will be there ready to undergo a kind of change. Okay, why? The reason is the system is undergoing a kind of change. Always do understand that the kind of solution that you're going to give to that particular team or particular project is definitely going to undergo the change. Okay, you are going to give a solution only. So the time that you had met the system, it's not going to be the same. The time that you are going to be with the system after a few amount of time, few days of time, few months of time. Is that clear? Very, very important. You should always have this particular thought in your mind, and with that kind of expectancy only, you have to approach the system. Okay, system will definitely change. Except the word change, everything will change. Okay, in the world, you know very well. Okay, so this particular circumstances, this particular situation is not be the final. It's not going to be the conclusion. It will have a kind of change in the future. Definitely change will be there. Even though currently there is no change is going to happen also, the system will function. The system might be getting developed with the kind of need that a change might occur at any point of time. Okay, that is what they're telling me. Persist throughout the life cycle. Life cycle, if you're taking, means not only the software development I'm talking about the whole of the system. Okay, to whom you're going for developing a project, that application development practices, what you're going for adopting, the tools, technologies, what you're going for adopting, the team who is going to develop the project. Okay, the kind of findings what the team has made, analysis what they have done, planning what they have fixed, the requirements what they have specified, resources what they identified. Okay, everything will have a change. Okay, but the change have to be triggered by some kind of thing which has to originate. That is nothing but the system which is in practice. Am I clear? The business which is in practice, the kind of service which is in practice, for whom you are going for doing a change, or for whom you are going for developing a project, if that particular thing is going to undergo a change means definitely you have to reflect that into your project. Okay, so that is what the first law, what you have to keep it in mind. So having got that particular thing as an introduction, we have to learn about the configuration management. We are coming into configuration management. The basic definition of the configuration goes like this, like the set of activities that have been developed to manage change throughout the software lifecycle. Change is predominant. We understood that inevitable or it's a significant thing for any kind of project. Okay. So what are the activities that you're going for adopting in order to manage the change throughout the software lifecycle? Here they are just targeting onto the software lifecycle, not the system lifecycle. System lifecycle is what? It is the system what is existing to us. But software lifecycle is what? It is the kind of practices what you're going for adapting to computerize a given system. Okay, so what are the activities that you are going to follow in order to manage that change? Okay, in the system through our software lifecycle or throughout our software lifecycle period. Is it clear? That is what the definition, what it holds. So don't think like the configuration management means we know software configuration, we know hardware configuration, right? We know these two types of configuration do exist for any kind of project. Okay, so we are trying to do some changes onto the hardware and software configuration level. But the change is not going to be one-time change. It is going to exist for throughout the project development lifecycle. Okay, so purpose is systematically control changes to the configuration and maintain the integrity and traceability of the configuration throughout the system's life cycle. Okay, in order to understand what is the configuration that the system is going to possess, what is the kind of record keeping activity that I can go for keeping on to the configuration related details of my system. I must go for systematically managing this particular configuration changes onto the system. Okay, so it is something like we are coming out of a project. And we are not completely coming out of the project. We are going to be there in that environment, but we are one layer outer. We are not so far, we were into the system, right? We were thinking about functionality. We are thinking about how to achieve this functionality in terms of our modules. Okay, which are all the areas that we need to go for emphasizing a lot in terms of our design or coding, like the only we are discussing so far. Now we are just coming one step further away, and we are going to think about the configuration management of the system. Is that clear? So that is what I'm telling. It's a kind of advanced thing that we need to look out for. So purpose is to systematically control the changes to the configuration. Control the changes to the configuration means keeping the change in track. Okay, getting to know about what is the change that the system is going to undergo. Systematically, we are going to make it. Procedurally, we are going to do that. And maintain the integrity and traceability of the configuration throughout the system's life cycle. So before going further into in terms of configuration management, we should understand what is a baseline. Okay, what exactly we call it as a baseline. It's a specification of product. Okay, the project is going to have some specification, no? What software is used for developing this project? What is the front end used? What is the back end used? What are the versions used for this development? Okay, what are the tools that are used? What are the components that are used? They are called specification. Definition of baseline is the same. Specification of product that has been formally reviewed and agreed upon. Okay, a specification which was formally been planned, being taken to the client, and what has been reviewed and what has been agreed upon. Agreeing upon means what? Two parties are involved. The developer is involved as well as the clients are involved. Okay, what is the kind of agreement that they have? Serves as a basis for further development. This particular baseline version of the document is going to serve as the basis for any kind of further development. Keeping this as an origin, we are just going for developing further. I already told you, like, if you're going to write a research paper or article, you should have a base paper. This base paper is going to serve as a basis for further exploration that you are going to do onto that particular topic. Okay, further findings that you're going to make onto that particular topic. You should not produce a base paper as such. Okay, we have to go for adding lots and lots of our own ideas and thoughts. But if at all you're asking like from where it was originated, means you can tell that the base paper is the one which is responsible for that. Similar to that here also, the baseline is going to serve as a basis for further development and can be changed only through formal change control procedures. So if this baseline or if this particular project which is under development using a baseline, is going to undergo or needs a change means it should be through formal change control procedures only. Formal change control procedure means it has to be properly reported. We need to go for properly specifying what are all the new changes that are going to be accommodated into that configuration of the system. It has to be taken to several people for their acceptance. Then only you can go for doing the change in terms of your development tool, in terms of your programming language or reporting tool or whatsoever it may be. It should be a formally changed control procedure which has to be conducted in order to do the change onto the product. So this is the basic definition for a baseline. One official version at any point in time. If you're going to take a project means, once the project is going to be developed and it is ready for deployment means, even though the project is going to undergo a number of changes later, we should always try to state that the project is going to have one official version at any point of time. At a random point of time, there should be one official version. Am I clear? It's not like the changes are not happening. Changes are happening at the back end or the background. But when it comes to the client level, when it comes to the user level, what you should see is like one official version at any point of time. Okay, now if you take Windows also, I'm not telling like Windows, no researches are happening, no changes are happening. They are working onto the source code. But what is available to us is what? The working version of the product. Any point of time, we can find like all this set of open-ended or closed-ended softwares will have one official version. Okay, signals the point of departure from one activity to the start of another activity. The baseline is responsible for that and helps control change without impeding justifiable change. Impeding is blocking. It helps to control the change without blocking the justifiable changes. Okay, we can go for controlling the change, but as a matter of controlling the change, we are not blocking any kind of changes to happen. If the change is very, very important, we are going for doing it. We are going for conducting it. Is that clear? So baseline is going to help us in terms of all the set of things which have been listed over here. It's a central repository of reviewed and approved artifacts. Artifacts means objects. Central repository of reviewed and approved objects that represent a given stable point. Okay, it's a kind of document which is going to possess the important details related to the reviewed and approved objects that represents a given stable point. Okay, shared database for project and kept in consistent state. Policies allow the team to achieve consistent state and manage the project. These are things in addition what a baseline is going to perform. We call it as a baseline documentation. Am I clear? The baseline of the product or baseline documentation of the product. This baseline documentation has got policies, okay, that allow the team to achieve consistent state and manage the project. What we call this a consistent state means the project is deployed and it is working fine. That is what we call this a consistent state. And if in case any kind of changes are required, we put that under managing the project or managing the system. Okay, but do understand that baseline is going to play all these vital roles. So this is a IEEE definition for a baseline. When you're learning, you can just mark it as important and learn. Sometimes in the 4 mark, it may be asked. A specification or product that has been formally reviewed and agreed upon that thereafter serves as a basis for further development and that can be changed only through formal change control procedures. Out of the previous slide, they have put the points in separation, they have put all together over here. That is the definition of from IEEE standards. Okay, so you can be a proud person stating that I am a member of this particular IEEE standard organization, a body which is going to give the standards for the technological innovations which are happening in terms of computer industry or science oriented industry. You are a member of it. That is what the advantage, one amongst the advantage that you're going to gain as a IEEE member. A baseline is a milestone in the development of the software that is marked by the delivery of one or more software configuration items and the approval of these software configuration items. SCI is called as software configuration items. Okay, approval of these SCIs that is obtained through a formal technical review. So baseline is a milestone in the development of the software that is marked by the delivery of one or more SCIs. Okay, so what is the change that has happened? So separate deliveries might be happening. Deliveries are not of the product. I'm not talking about the product here. I'm talking about the software configuration items, the changes that has happened. Okay, that also you are going to deliver at different points of time or different periods of time. Okay, what are the changes? So having told that the change is inevitable, change is unavoidable, change is significant, definitely it is going to happen in the lifetime of a project during the development phase or after the deployment phase. Anytime we can expect the change to happen in the project. Okay, it's a project content is going to change, a project development environment is going to change, a configuration as a result of it, it is going to change. We should clearly understand what are the changes that are going to happen to the system. First changes in business requirements. Okay, this is what I was stating so far. Business, what it exactly requires. From there only it originates. A change originates. Okay, the person is going to come out with this is the way the report was generated so far. I don't want hereafter in this way. I want in a different format. There is a change in the requirement. Is it clear? This is the way out as the transaction was happening so far. Hereafter, I don't want the transaction to be happening in this particular bank environment or in this particular interface level. I want to change the structure. Okay, I want to go for adding some kind of advanced encrypting algorithms. Okay, so far it is happening with in terms of a PayPal kind of planning or paying a payment procedure or the existing Paytm kind of applications. I want to create my own payment portal. Okay, so there is a kind of change. Anything, it's totally unpredictable. It's highly dependent upon a customized over the system which is in practice over there. Is that clear? So changes in business requirements, changes in technical requirements. So that will give rise to a change in the technical requirement. Okay, business requirement change will give rise to a change in technical requirement. Accordingly, we will go for requesting the requirements related to the technical aspects of your project development or the project execution. It may be like a programming language change, or it may be like any kind of tool change. It can be any kind of component change, anything it can. Okay, but remember that there is a demand for this particular change to happen. The demand is going to originate from the business requirement. Okay, after the change in technical requirement, we are going for changes in user requirements. So when the system is going to demand some amount of technical thing, user, in terms of making the technical thing to happen or making that particular resources to exist in his project, according to the technical requirement change, we have to go for a user requirement. So that user requirement will also undergo a change. Say, for example, new software is added onto the system according to the business requirement of the product. Okay, now technically I had introduced a new tool over there, but I don't have resources. Okay, I don't have the people to work on to that. They don't have the time to go for any kind of training. Okay, so it's a kind of change, or it's a kind of immediate requirement needed from the user level. Okay, user level means what? Somebody might be requiring this particular change. Okay, it is not like an unknown person we are going to tell him as a user. A person who is developing a product, a person who is going to utilize a product, they will have a kind of change in their requirement. Is that clear? So how to meet all these requirements means, once again, we are going through all the processes of software development. A project plan is conducted, a software model is going to exist, testing is going to be made, coding is going to be done, data are going to be considered, and other documents are going to get generated. Okay, so in order to make this change in user requirements to happen, we are going to follow any of the software development models only. Most preferably, you can go for a waterfall model, or you can go for a prototyping model. Okay, and when you are going to follow this particular model, they are going to have a kind of resemblance in terms of the generic way of software development, like project plan, test, code, data, and other documents. Is that clear? So these are the changes that might happen in the trend, or when your project is going to keep itself scaling up according to the changes that are happening in the business environment. Am I clear? Understood. And the next one, SCA, about SCA, very important topic. You can mark it as important. What software configuration item is all about. The basic definition of SCA goes like this: information that is created as part of the software engineering process. Okay, that software configuration items are nothing but it is the information. It is a set of details that is created as a part of the software engineering process. Software engineering, as I told you, like even updation is also a part of software engineering only. Maintenance is also a part of software engineering only. Modification is also a part of software engineering only. So what are the kind of information that you are going to generate as a byproduct? Okay, that is what we call as the software configuration item. Is that clear? So what might be the content of the software configuration item? We may have the set of tools, technologies used for developing. Am I clear? So while we are going for stating like technologies and tools used for developing means, you can tell that, or you can state that these are the configuration used for the project. Okay, these are the set of things that are used or that are utilized in the project. And you can tell that this is the version that is used. And this document will definitely be there as a part of the general documentation of my project. I'll be going for creating the hardware specification and software configuration. If you're asking me to generate hardware and software configuration also, I will give relevant details related to this SCA items only. Is that clear? So example goes like this, like software project plan. That is a software configuration item. Okay, software project plan. What is it? It is a component of it, right? What is the version? Here for the project plan, you can come out with versions. Version 1, version 1.1, 1.2, 1.3, and so on. And each version might be linked with a year. Okay, year of its release. When it was started, what is the month that it is configured, everything, software project plan. Then software requirement specification, models, prototypes, requirements. Okay, SRS specification. Models, prototypes, requirements are nothing but, you know already very well, like we have specification models, we have prototypes, rules and regulations to follow, some kind of model which is going to get evaluated for its correctness. And based upon that, we are going to come out with the requirements for the project. Okay, so this particular SRS also can be considered as an SCI, software configuration item. Okay, then the design document. I'm not talking about the design document. Why I'm not talking about the design is design is the actual product. Am I clear? So I cannot tell that this is a configuration. Design is what the people are going to look for and whom are going to interact with the project. Okay, onto what they're going to interact with the project. So it's the project. Is that clear? But the design is not alone, it is with the design document. That design document is my software configuration item. Am I clear? So it is understood that documentation is mandatory here. Okay, we cannot avoid that. We cannot skip that documentation. Okay, we cannot avoid that. So documentation is also a part of software configuration item. Then we have something called source code. So now you can ask a question, sir, why source code is a SCA item? Because without the source code, the project is not going to function. Design is not going to function. Then how I can just term it as my SCA item? The reason is source code is not going to be dealt by your client or the user or the customer. Okay, only you have the source code. You know the source code. Okay, you have the rights to access the source code. So while you are just going for fixing up what are things to be the software configurable items means, you can state that a source code is also a CA item. The reason being, nobody is going to interact, but it is a very important component for the project. So design, having given a design, if at all you are going to make the design to run, or if at all you are going to execute the design through the source code only, you can expect the project to happen. So you can put that source code under the SCA component. Is that clear? Then test suite, what we are going to create, test suite, what we are going to have, the test related data, okay, everything, and the software tools, example, compilers, interpreters, then device drivers, the ones which are responsible for the project to work, or ones which are responsible for even your editors is also a part of your software tool only. Is that clear? Editor used for typing in the program, viewing the program, doing some changes onto the program, and configuring the program, building the logic, the editor, what you're going for utilizing, that everything are software tools over here. Remember, here software means I am not talking about our product. I'm talking about the set of tools which are used for developing the project. They are also a software component only. Is that clear? So these are all software configuration items. So if you're looking out into, they're just given just programs, documents, data, which are the pieces of the software configuration items. And these are the objects which are given in much more a refined manner. Okay, next level, if you're going to go into, you will find these things as a software configuration item based objects. Okay, what are they? Design specification object, test specification object, data model object, component object, and source code object. You can ask, like, sir, what is diagram, sir? First time I'm seeing this diagram. I haven't got any knowledge about this diagram. These are all nothing but your object diagram. Am I clear? While you are learning, you may learn as a part of a UML, the class diagram, object diagram, and all those some 8 or 9 diagrams are there. So this object diagram is one amongst that, and this object diagram is used for representing all the software configuration objects. Okay, a design specification object is there. We have a test specification object. We have a data model object, component object, and a source code object. They are all items. Am I clear? So if you're asking design specification object means, so what it is, the contents of the design specification object means a data design, architecture design, module design, interface design. You know about all these designs. You cannot tell that, I don't know about a data design, because as you go for constructing a structure of your data, You are literally designing the data. Am I clear? Do understand that. You are going to create a data structure. Okay, that is a component. So that is nothing but your design data. If you are going for giving specification to the data, that is what should it should be an ordinal data, it should be a primary key, it's a foreign key data. You are going to put some parameters onto the data. You are going to fix some data type onto the data. This particular variable is going to be of this particular data type. Okay, like the way if you're going to make this, you are literally going for designing the data. Okay, we are doing it, but without having the knowledge, we are doing it. When somebody is asking what is the phase that you are right now into the project means, sir, I'm creating field, I'm creating variable, I'm creating data structures means, it tells that you are now to have the proper knowledge or awareness over what exactly you are doing over there. Okay, you are designing the data. Am I clear? Then we got something called architecture design. Already we know what is an architecture design is all about. Module design also we know. Interface design is also we know. So architecture design, module design is otherwise called as a high level design. Interface design is otherwise called as our low level design. All the design comes under design specification. Okay. So while you are developing a project, this design specification, what you are actually doing while in the process of making the design to come out, exist in the project. Then we have something called as test specification object. So what is test specification object is going to have is, it is going to have test plan, test procedure, and test cases. Test plan is nothing but the plan what we had created for conducting the test, ensuring that quality of the product is met, are going to be met. Okay, for that we are going to create a test plan document. Then we are going to come out with the test procedure. How we are going to make the test plan to happen? How we are going to bring the test plan into practice? That is test procedure. And you are going to create some test cases. The things which we identified, like there might be a vulnerability which needed to be tested for its quality or correctness or importance. Okay, so that entire three things comes under test specification. Then we have a data model. Okay, maybe like any of the database model that we learned, relation data model, hierarchical data model, entity relationship model, any model you can go for taking over here. And then the component, interface description, algorithm description, and PDL. I'm not getting exactly what exactly this PDL is all about. Maybe related to documentation. Okay, if at all I'm not wrong, maybe related to documentation. But interface description, you know what it is exactly, giving a kind of theoretical details related to what each and every interface forms are going to do for the project in order to make the project to happen, in order to make the project execute. Then we have algorithm description, which is nothing but a coding description. Okay, the kind of help or a kind of comment oriented statements, what you are going to give for each and every logic, what you have created for the solution for the given problem. Okay, which otherwise called as algorithm. Okay, and then finally the source code. So source code is also a configurable object. As I told you, like it is not going to be taken to your client. Okay, it is going to be taken only within us, and we are going to make that project to work as a result of the source code according to the essence of the functionality. So all these things are going to be a part of our software configuration objects. Hope you have an understanding of it. Okay, so the software configuration item only we are just going to learn in terms of different title level. Okay, and the next one is what we call as software configuration management repository. The SCM repository is a set of mechanisms and data structures that allow a software team to manage change in an effective manner. Now, change is unavoidable, that we learn. Okay, some kind of way should be there in order to properly control, manage, and track the changes. Okay, remember, product development itself is a very complex task. Okay, and understanding what are the requirements for going for an upgradation, that is another challenge. And making that upgradation to happen, okay, bringing that upgradation into reality, that it's very huge challenge. You are going to disturb a successfully running system now. You are going to do some changes onto the system which is already existing, which is already been proven. Okay, so you have to properly manage, you have to properly track, you have to properly follow the kind of changes that are going to happen onto the system. Okay, so software team has to do that. In terms of what they are going to do this particular tracking is in terms of the mechanism used in the project along with the data structures. Is it clear? So the repository performs or precipitates the following functions like data integrity, information sharing, tool integration, data integration, methodology enforcement, and document standardization. Repository performs the following functions. So if you take a SCM repository, or if you're going to consider that software configuration is managed or it is going to undergo a change or update is going to happen means it is these things are going to get an upgrade. Data integrity, okay, the kind of trustability that you're going to put onto the data, making the data more secure. We are making n number of the researches are happening day and night together in order to make how to safeguard the data, okay, in much more a productive manner, in much more a safer manner. Is it clear? So unknowingly or knowingly, our entire life is in the hands of a cloud, okay, a cloud-based environment. Our information is stored everywhere elsewhere. Okay, so it is this reason or this need that has emerged in order to secure the data. So what is the kind of trustability that we are going to have onto that we are going to access the kind of data which has not been impeached by someone, which has not been changed by someone. Okay, so data integrity is a prime factor over here. Information sharing, you know very well what is the importance of it. Tool integration, how to go for practicing all the case tools while we are going for developing a project. Okay, data integration modules. Data are going to get integrated from different scenarios, different areas. Okay, which are having the access over to the data. Then methodology enforcement, document standardization. So these are the functions which are being tracked by means of this SCM repository. So a repository means it is a collection, okay, wherein we are going to collect the kind of changes that are going to happen onto the product as a whole. Okay, so in terms of these functionalities, the SCM is going to keep the data content. Is that clear? So these are the features of this repository, like versioning, dependency tracking and change management, requirements tracing, configuration management, and audit trails. Okay, these are all maybe like you might be hearing for the first time, even though these things might feel like a very familiar topic for us. We are learning about it for the first time, and they're very crucial also. They're very important also. Okay, versioning saves all of these versions to enable effective management of product releases and to permit developers to go back to the previous versions. What are the versions that has come? Okay, version 1, version 2, version 3. What is the kind of upgrade that has happened onto that version? Okay, not only version number it's going to store, it is going to have the details of what is the upgrade that has come onto the new version. Even those upgrades are revealed to us. Am I clear? It is not they're keeping it hidden. If any kind of operating systems are going to get a kind of upgrade, means they'll tell what is a new set of features that are added over here. If you see this Apple's major releases of their operating system and all, you can find like pages and pages of updates to happen over there. Am I clear? So they have to maintain that versioning data into the repository. Okay, so that is one of the characteristics of this repository. It is going to possess the version related data and the kind of changes that are happen onto the product. And if in case, okay, if in case the user wants to or the developers wants to go back to the previous versions, they should be allowed to go back. If that repository is not going to possess all those details of the previous versions, okay, they will not have an option to go back to the previous version. They are forced to work with the current version, even though they don't like. Many times it used to happen, no, when we are going for upgrading our OS, if at all our system becomes slow, okay, our mobile becomes slow, the movement of our screen is not what to tell in a smoother manner. The screen is just breaking in between, or the smoothness of that movement between our navigation is not properly being felt. Okay, that's the reason why we are going for 120 hertz display ratio and all. Okay, so it's not smooth. After the upgrade only it has happened. Means always we are free enough to go back to the previous versions. So if the previous version is not maintained, if it is not being kept in their repository, means people will be losing that option. Is it clear? So that is the importance of versioning. That dependency tracking and change management. The repository manages a wide variety of relationship among the data elements stored in it. So within the repository, it is also like a kind of project only. Okay, we are storing the information related to all these functionalities. Okay, so in what way these functionalities and all are considered means they have a kind of relationship amongst each other because they all belong to a product only, right? So they will definitely have a kind of link. They will definitely have a kind of communication amongst each other component. So that is what we call it as a dependency tracking and change. The repository manages a wide variety of relationships among the data elements stored in it. Is it clear? And the next one, requirements tracing, provides the ability to track all the design and construction components and deliverables that result from a specific requirement specification. It is specific requirement specification responsible for all the set of changes to happen onto the product. With respect to the design, with respect to the construction, with respect to the deliverable, what is the change? What was the previous version? What is the current version? Okay, don't feel like, sir, why I am going for having a kind of tracking, or why I'm bothered about the deliverables. Already I learned about these things in software planning. That is in terms of regular software development. This is in terms of over a product, a completed software development, a completed software product. In the name of doing some changes onto that, in the name of giving the upgrade or update onto the product, we are accustomed to go for doing this set of tracing. Okay, track all the design and construction components and the deliverables that result from a specific requirement specification. Am I clear? So we understood that SRS is there even for undertaking the changes in the product. Is it clear? Upgradation in the product. That understanding we got now. Then configuration management keeps tracks of a series of configurations representing specific project milestones or product releases. Version management provides the needed versions, and the link management keeps track of interdependencies. Okay, so overall thing we are going to take into consideration to configuration management, not only in terms of the hardware component, not only in terms of software components. We are going to take care of the version management. Okay, we are going to take care of milestones. We are going to take care of the set of links that are going to emerge out of it in terms of interdependencies. Everything we are going to consider as a result of configuration management. Overall configuration management. That is what we have to keep it in mind. Is that clear? And finally, audit trails establishes additional information about when, why, and by whom changes are made. Whenever audit means, every company used to have a kind of threat. Okay, the reason is during the audit only, individuals are being pinpointed, individuals are being targeted. Okay, because certain kind of change has happened, certain kind of functionality has happened, and the functionality is a successful functionality or some kind of glitch is there onto that means individuals have been identified. Okay, so what does this audit trail is going to do is it establishes some additional information about when, why, and by whom the changes are made. Who is responsible for this? Is it clear? Why that has to be maintained is we need to have a kind of we need to have a kind of tracking that if in case any kind of change is not a successful change or it is creating some kind of failure for the entire system means that person have to be called and he has to be given the right kind of awareness and he only has to rectify the error, rectify the kind of changes that is done onto the system. Okay, for that audit trails are required. So these are the features of the repository. What exactly SCM process is all about? Few more slides are left out. Let me finish it off. Okay, what software configuration management process is all about means. Okay, now we are understanding the process. So far we learned about the repository features. Now we are coming into the actual process. It addresses the following questions. How does a software team identify the discrete elements of a software configuration? Discrete elements means different varieties of elements of the software configuration. This one addresses. Okay, the software configuration management process, it gives an answer to that. Who is doing that kind of discrete elements of software who is going to deal with that? Who is going to identify that? The software team. How they are identifying it? The SCM is going to give an answer for it. Okay, this was the functionality requirement that has came out of the original product after delivery. As a result of it, the team has identified variety of options, okay, related to satisfying the requirements, which is nothing but software configuration. Am I clear? How does an organization manage the many existing versions of a program and its documentation in a manner that will enable change to be accommodated efficiently? Okay, to consider the kind of change, to consider the kind of upgradations, how does the team or how does the organization is going to accommodate it in an efficient manner? While we are going for looking into the operating system release, you can see that like one concrete product will be the release. Is it clear? It is not something like they have a kind of doubt over whether we are releasing the most better product, most upgraded product, most viable product, optimum product or not. All are being answered. With that answer only, they are hitting the market. They are hitting our devices. Is it clear? So how does an organization manage the many existing versions of a program and its documentation in a manner that will enable change to be accommodated efficiently? Okay, how they are taking it, the existing version, and how successfully, how daringly they are bringing in the changes onto it. Okay, how did they done that? Even documentation is also going to undergo a change. While you are going for doing the change, you should not take up only the functionality aspect. You have to look out the documentation also, because it has to properly update it. Am I clear? How does an organization control changes before and after software is released to a customer? There are changes which might happen onto the product before the release also. Okay, because you are taking good amount of time. Meantime, the system has undergone many number of changes. The person has started his own branch over there. He has established his organization. Okay, because we have taken some kind of model which has utilized a lot of time for development. Okay, so before the change, we have to undertake all those changes, all those modifications or developments, and after the release of the product, there are certain changes which is recommended, which is requested by the client. That also we need to go for properly managing. So that answer and all SCM is going to give. Who has responsibility for approving and ranking the changes? Who is responsible for finally approving and ranking the changes? Why the ranking of the changes? What change to occur first? What has to occur next, and so on. Is it clear? After giving the approval, they'll be hierarchizing it. They'll be going for giving the kind of numbering onto it. Which change has to happen first, which change has to happen second, and so on. According to, yeah. Who is this? Prem? Prem, what happened? Okay. So how does an organization manage the many existing versions of a how does an organization control changes before and after software is released to a customer? Okay. And how as responsible for approving and tracking the changes, how can we ensure that changes have been made properly? That is another very important challenging thing that we need to look out for. The changes happen means whether changes successfully happened or not. How can we ensure that? What are all the things that you had identified from the project that you consider that okay, the change is a successful one? We have to go for giving answers to that. What mechanisms used to apprise others of changes that are made? Okay, appraisers. While somebody is doing a change, it's a successful change which has answered the kind of challenge that has been put forwarded by the real-time system. We have to go for appraising them. Is it clear? So what is the mechanism used by the organization? Then and there incentives are provided, you know very well, by software developer organizations for developing the product, coming out of the release of the product, or doing some kind of changes onto the product, everything. Okay, so these are the things that SCM process is addressing. Okay, and these are all the steps that will happen over there. Like software configuration items, over the software configuration items, what we have studied so far, identification is happening, change control is going to be done, and version control is going to be done. Configuration auditing is going to happen and reporting is going to happen. Don't start from here, start from the innermost ring. Okay, so each and everything we learned in the previous slides. And detailed information is given on version control. Kindly go through this. Okay, version control, change control process and all. This and all like an algorithm in a stepwise pattern format they are given. Change control process if you are taking, need for change is recognized, change request from user, developer evaluates, change report is generated, change control authority decides, request is queued for action, and change control process 2 is going to be executed. A request is queued for action. Parallelly, we are going for change request is denied, user is informed. Because change control authority deciding means he is going to decide whether to go ahead with the change or to deny the change. Is it clear? So a change cannot be accommodated at all. Okay, because system is going to undergo a major modification, and as a result of it, system may not function appropriately according to the expectation. Is it clear? So change request is denied and the user is informed. Is it clear? So this is a set of processes that are happening in the first stage. And second stage, assign people to SCI. So if that request is sanctioned, means assign people to software configuration items. You are responsible for taking up this particular item. You are responsible for this particular configuration change. Like there, you are just assigning people. Check out the SCIs, make the change, review or audit the change, establish a baseline for testing, and go for change control process 3. Now, the change has happened. Okay, whether change is successfully happened or not, everything will be done during the review or audit. Okay, change is successful. Now, after the success, we need to test the product, correct? Because the product has undergone a change. We need to test the product, where the change, after the change, product is working fine or not. For that, we need to create establishing a baseline for testing on to what we need to do the testing. Which are the areas are being found that risk is existing, risk of failure may exist, risk of quality defect may exist. Okay, so those things and all you need to establish a baseline for that and leave the project to a process 3 for a QA. Here, perform software quality assurance and testing activities, checking the changed SCIs, promote SCI for inclusion in next release, rebuild appropriate version, review or audit the change, include all changes in the release. Now, test is done. It's a quality change. Is it clear? The product still does not compromise anything onto the quality. That will be revealed over here. Checking the changes, change the SCIs. Again, get into the change SCIs and promote SCI for inclusion in the next release. You have done some software configuration items. You have chosen some items which from the project, which a change has to be done. You have done the changes. Include those changes into your product, okay, and go for the next release. Now, the next release product will be the one which has accommodated the change, which has included the change, which has integrated the change, and it is the most latest version. So what is the point over here? What is the beauty of this particular process? The original product remains undisturbed. Am I clear? Only that software configuration items over the product which requires a kind of change only we are doing it. And the original product is still available for the client for his use. And after one fine day, maybe like any unofficial hours, we can go for doing that inclusion and release the product as a next release. Rebuild the appropriate version, review or audit the change, and include all changes in the next release. Okay, so this is what change control process 1, 2, and 3 are about. So these are all the part which comes under SCM process. Okay, so question might be asked as to explain the SCM process, sorry, software configuration management process, you have to go for completely explaining that. Is it clear? So these things are not so much of greater importance. We can skip it off. Okay, with that, this part of software configuration management, which comes as an advanced topic in software engineering, is concluding. Okay, with this, the things what I need to go for delivering you as a content is ending up. And what you need to go for learning is about the secure coding practices and computer aided software engineering tools. Now, so please note it down. These two topics are given to you as a self-learning topic. Is it clear? With that, the module is concluding. Okay, is that fine? Guys, are you all there? Please turn your video on.
Yes, sir.
Yes, sir.
Please turn your video on, everyone.